All right, let's start with some exponents, which will kind of tie into the whole radical thing. There's nothing from 4.1. All right. All right, let's look at 1a. It says if x is greater than 1, then which one is greater, x to the negative 2 or x to the 2, and y as well. So for example, we have, let's say x is 2. Greater than 1 means something bigger than 1. So let's say x is 2. Is 2 to the minus 2 bigger, or is 2 to the 2 bigger?
2 to the 2.
2 to the 2 is bigger. What if x was less than 1? Let's say x was 1 over 2. Then which one will be bigger? Is this bigger or is this bigger? 1 over 2 to the negative 2 or 1 over 2 to the 2?
1 over 2 to the negative 2.
Right, because this is 4. Here, let me show you how that's 4. Because when you move this 2 in the denominator to the numerator, it becomes 2 to the negative 1, and this 2 on the outside is still there. That becomes 2 squared, that's a 4, whereas this one is simply a quarter, or 0.25. So if x is bigger than 1, then this is going to be bigger. If x is less than 1, which is the answer to the next question, this is going to be bigger. And if x is exactly 1, then they're equal. Graphically, this is what it looks like. If x is bigger than 1, then your function would look like this. Let me use a different name here. Let me say b. B as in like the base. If the base here is bigger than 1, then it's going to look like this. And here are your x values. If your base is less than 1, so this could be an example of 2 to the power of x. If your b is less than 1, then your graph would look something like this. So b being less than 1 is winning or is bigger to the left of the y-axis. B greater than 1 starts winning to the right of the y-axis, and it exactly on the y-axis, which means when the x value is 0, for both of them, the y value is exactly 1. Let's try doing these guys. It's not too bad. If you know your rules, they're like gonna be 1 or 2 steps. What do we do with the exponents here?
You add them.
You add them. So it'll be negative 7 to the negative 1. Is that positive 7? What is negative 7 to the negative 1?
It's 1 over 7.
It's 1 over positive 7, you said? Like this?
Mm-hmm.
Nope. Remember, whenever you switch it up or down, it's only the exponent that changes. So it's going to be 1 over negative 7, which is pretty much the same thing as 1 over, or negative 1 over 7. But the negative sign needs to go down with it as well. Okay?
Mm-hmm.
What about for D? So 4 to the negative 10. The first term stays as it is. What's the power for 4 on the second term?
-18.
Negative 18. In the denominator, you have negative 32, right?
Mm-hmm.
And in the numerator, we're multiplying them. That means you need to add the exponents. It's going to become 4 to the negative 28. In the denominator, we get negative 32, like that. This is going to move up here. That'll become 4 to the negative 28 plus 32, which is 4 to the power of 4, whatever that is. That's 256. And you are done. Easy peasy. All of these are like 2 steps. Like here for B, look at this, how easy this is. You're just gonna move this up there, right? All you're gonna do is you're gonna move the denominator up there. What's gonna be the power of 2?
5.
5, and you're done. What do we do for E?
You add the exponents.
You can't add them right now because the bases are different. One of them has a base of 11, whereas the other one has a base of 1 over 11. To add them, you need to make sure they have the same bases. So if I move this 11 up, what's gonna be its power? If we move this guy here,
-7.
yeah, it'll be -7. So you have 9 minus 7, so it'll be 11 squared, which is 121, and you're done. For bigger problems, you want to work inside out, so you want to go in like in this direction. You could work at it like this, you could kind of squeeze it in, but it makes things more difficult. Doesn't apply to C, but would apply to F. We're gonna work inside out. So let's look at C. C is a one-step answer. You get what, 5 to the 3 on top over 5 to the 3. What is this?
It's 1.
That's 1, yeah, and you're done. Okay, for F, what we do is we're gonna first work on the inside 3's. We'll leave this -3 on the outside. You could also move this upside down to make it positive. Let's do that. To make this positive, you need to move the denominator to the numerator, like that, and the numerator to the denominator, if you want to make the exponent positive on the outside. From here, it becomes -3 to the 12, -3 to the 11 on the top and the bottom. There's a 3 on the outside, so the answer is -3 to the power of 3. And you're done. It's -27, that is. This one, it says, express the radical in exponential form, and vice versa. So let's look at this one. Cube root of x7. How would you write this in an exponential form? Exponential means we can't have any roots.
X to the power of 7 over 3.
Yeah. Okay, what about B? You want to write this as a radical now.
The 5th root of y to the power of 8.
That's it. What about C? So if it has a root or a radical, you want to write it in exponential form. So all you have to do here is to move something around.
P to the power of 1 over 2.
11 over 2.
Mm-hmm.
And for the last one, what about for the last one? So we need to write this in radical form. Nope. It's pretty simple. It's just, maybe it's not that simple. I guess the question is, what is 1.25 as a fraction? Okay, here, let me show you. What is 1.25 as a fraction? You can rewrite this as 1 plus 1 over 4. Do you agree?
Mm-hmm.
What's 1 plus 1 over 4? It's 5 over 4. So you have m to the 5 over 4, which means it's the fourth root of m5, and you're done. To here, we need to simplify all of these. Let's look at A. We have 2 over 5 to a negative 3 exponent on the outside. What's the first step?
You flip the fraction.
Yeah. You flip it, it's going to become positive. So it's 5 over 2 to the 3. What's 5 cubed?
125.
Yeah. Over 8, and that's the answer for that one. What about B? What do we do?
You flip the fraction again.
Mm-hmm. So 225 over 16 to the 0.5. What now? Are we done? Is it as far as we can go?
You can turn the 0.5 into 1 over 2.
Mm-hmm. So it's something like this. Square root of 16 is a 4. What's the square root of 225?
15.
Yep. And that's the final answer, and you're done with that. For C, can we flip it upside down?
No.
No. It's because the negative 0.25 doesn't apply to the denominator. So what do we do? So the denominator is not that hard. What's the cube root of 125?
5.
Yeah, so cube root of negative 125 would be negative 5. So that's that. But for the numerator, what we do is we're going to bring this into the denominator to make the exponent positive. So it becomes 81 to the power of, remember, 0.25 is 1 over 4, which is the same thing as the fourth root of 81. What's the fourth root of 81? It's a nice whole number.
3.
3. So you get negative 5 times 3, so the final answer will be 1 over negative 15. And you are done. Easy peasy. Alright, so cube root of negative 27 is negative 3. To the power of 4, that is 9 times 9, 81. Fifth root of negative 32 is negative 2. Sixth root of 64 is 2. So we have negative 2 times 2 power 5. That's negative 2 times 32. That's negative 64. This one, on the inside, it becomes negative 2 to the 6. What's the sixth root of negative 2 to the 6?
Negative 2.
Negative 2. The roots cancel each other out, and you're done. So that's the answer. Again, most of them are just 1 or 2 steps. You just have to know whether to add them or subtract them. Right? That's pretty much it. Nothing too fancy here. Let's look at A. What's the answer to this? A is very simple. The answer is a nice whole number. Even though we don't know the base, we know the answer to A.
It's 1.
It's 1. It's A power 0, it's 1. For B, it's B power 1. This -2 goes up there, becomes a plus. 0.8 plus 0.2 is a 1. For C, you can do this in one step. Look at this. This C has a power of 1. You're multiplying another C, that if you're multiplying, you add the exponent, so it becomes 1 plus 5/6. And C2 is in the denominator, you'll end up subtracting it like this. Yeah?
Mhm.
Now look at this fraction addition. This needs a 6, 6. This needs a 6, 6. So it becomes C to the power of 6 plus 5 minus 12/6. So that's C to the -1/6. So the final answer will be something like this. You throw it in the denominator to make it positive, and the 6 in the denominator in the exponent is the index, and you are done. For this answer, could we evaluate this for C equals -2? Does an answer exist?
It doesn't,
Why not?
because you can't do like an even root of a negative number.
Yeah. So what about if it was like this? Could you evaluate it then? I put a square on the C.
Yes.
Yeah. Then the other thingamajig would become positive, right? Because if you put C as -2, it would become positive, correct?
Mm-hmm.
What does this mean? Let me show you graphically what this means. So what were we looking at? We're looking at something like, notice how this doesn't go into the negative x-axis. Because if you put a negative x value in here, like -5, -10, you get a negative number inside the square root. But if I square this, can we have negative x values? I'm just gonna square this x. What do you think? It's the same thing as this. If we square that x, would I be able to input negative x values?
Yes.
Yes, right? So how is the graph gonna change? You'll basically get the exact same thing to the left of the y-axis. It's gonna be a mirror image. And there we go. That's what it looks like. Now it can take negative x values. But can it take the value of 0? Can x be 0 here?
No.
No, because then you'd be dividing by a 0, which is not possible. So the domain of this function is x can be anything except 0. Part 6. I can quickly do this in 10 seconds. Maybe not 10. Maybe 10 seconds each. And again, remember, we're just adding the exponents or subtracting them. That's all this entire topic is. D to the -5. We add this with 11/2. And then do we add or subtract the 6 from the denominator?
Subtract.
So you would subtract the -6, which becomes a +6 like this, right?
Mm-hmm.
And this becomes D to the 11/2 plus 1. And 1 is just 2/2, so it becomes D to the 13/2. And that's it. For E, what's the exponent? we just multiply all three of these numbers up. So it'll be -2 times 7/2 times -2. Negative sign and negative sign cancel out, becomes a positive. And you can cancel out one of the 2's with the 2 in the denominator. So negative and negative gone, and 1, 2 is gone with the 2 in the denominator. So it becomes e to the 14 as your final answer. Same thing for f. Look at this, it's very simple. Because it's an exponent within an exponent, and our exponent law says we need to multiply the numbers, just like we did in part E. The negative sign cancels with the negative sign, right?
Mm-hmm.
The 1 is redundant, so you can completely ignore this one. Negative signs are gone. So now you're left with 1/6 times 6/5. The 6 cancels with the 6. So all you're left is f to the 1/5. And that'll be the final answer. You could write it like this, I guess. 5th root of f, same thing. Explain why a plus b is not equals to a plus b for a equals 0 and b equals 0. How'd you show this? All right, this is how we're going to show this. Let's say you have a plus b. Let's square this. What would you get?
A plus B.
Yeah. Now let's say you have this. You square it. What would you get?
A
Is it
plus B.
is it the exact same thing is the question, I guess. So no. This is a little bit more trickier. There is gonna be an a plus b in there, but there's gonna be an extra term here. Let me show it to you like this. Or actually, I want you to start using this. This will save you a lot of time. The formula for a plus b whole squared is a squared plus 2ab plus b squared. So using this, let's open this bracket. So a squared means the first term squared, like that, plus 2 times a, the first term, times b, the second term, plus b squared, which means the second term squared. Then you would get a plus 2ab plus b. So that's what it actually opens up to. Now let's compare this with this. Are they the same?
No.
No, they're not. This will always be bigger, right? Because there's an excess term here. This will always be bigger. Because the squares aren't the same, these two expressions without the square also are not going to be the same. This will always be bigger than this, okay?
Mm-hmm.
For a quick numerical example, you can do this. Let's say a is 16, b is 9. For this one, it becomes 16 plus 9, 5. For this one, it becomes root 16 plus root 9. That's 4 plus 3, that's a 7. Notice how this is bigger than this? And that's always going to be the case, because when you square them, you get an extra term, which means even without the square, this should be bigger than the other one. This is going to be annoying. And it's all like 2-3 steps. Look at this. So the x's, how many x's do we have for A if we open those brackets? Remember, the exponent applies to every term inside the brackets. So for A, when you open them, this becomes 5 squared times x squared. For the other term, it becomes 2 cubed times x cubed, like that. This is 25 times 8. What's the power of x?
5.
5. So then you have 200. 25 times 8 is 200 times negative 2 to the power of 5, because x is negative 2, and that's negative 32. You just plug this in a bracket, in a calculator. It becomes negative 6,400. And that would be the final answer for A. For B, what do we do for B? Same thing, we're just gonna open the brackets. It becomes 2 to the negative 3 times m to the negative 3. Anytime you have a negative exponent, you want to switch its position. So I'm going to move this up here. What do we get if we move that 2 to the negative 3 to the numerator? It becomes 2 to the positive 3, right? Like that?
Mm-hmm.
Times 8. That's 8 times 8, that's 64. And on the bottom, I threw that negative 5 down, which made it positive 5. You get m squared. And then finally, you can plug the m value of 4 to get a final answer of 64 over 16, which is a 4. And you are done. Is that difficult?
No.
It's all just very tedious. Let me do 1 or 2 more. For this one, does a negative 1 apply to the 6?
Yes.
Yes, it does. So for this one, I'm gonna work from inside out. So this becomes 6x to the negative 12, negative 1, becomes 6 to the negative 1 x 12. We're gonna throw that 6 to the negative 1 in the denominator like this. And then finally plug the value of x and whatever that is on a calculator. For this one as well, look at this. We are gonna open all the brackets. And when you're doing this, just remember the exponent applies to everything inside the bracket. So in the numerator here, that cube also applies to that negative sign. Becomes negative 2 cubed, x to the negative 6, 6 squared, x squared. 2 times negative 3 to the 3 times x to the negative 1 to the 3, I guess, which is x to the negative 3. Now what do we do? Now we're gonna group up the numbers together. So we have 1 thing here, 2 thing here, and 3, 4, 4 numbers there. Negative 8 times 36 over 2 times negative 27. Those are just the numbers. For the x's, it becomes x -6 plus 2 plus 3. So the x will have a power of -1, which you can also throw in the denominator. So the final answer will be this entire thing in a calculator with an x left over in the denominator. And then you can replace this with 1/2 or 0.5. So again, all I did was I opened the brackets in order, remembering that the exponent is going to apply to everything within that bracket. What's the answer to A? It's a one-step final answer type of a question. What's the answer to A? That index is going to apply to everything inside the radical. So what's the cube root of 27?
3x times y to the power of 3.
Yes, and that's it. One and done. For B, we have to play around with this a little bit. Move the A6 down and move the B3 up. Then you'll get something like this. What's the answer to this?
B array.
Yeah. For the last one, 1.5, 3.5, we're gonna move the 3/2 in the denominator. -2, -1.5. We need to move the n to the denominator as well to make it positive. Like that. So the final answer will be m squared and n to the 1/2. And that's it. Easy peasy. The next few may be slightly more difficult. Let's look at D. Fourth root. We're going to leave that as it is. What's going to be the power of x in the denominator? What's 4 times -11/2?
-44/2.
So that's -22. Up top we have x to the -16. Can't do anything with that just yet. This becomes x to the -36, right? Like that.
Mm-hmm.
So now we have fourth root of x to the -52 over x to the -22. What's the fourth root of x -52? Can we simplify that? Yes, we can. Just bring the index inside into the denominator. This becomes x to the -52/4. Remember, the index goes in the denominator. And then we simply move this 22 upstairs into the numerator to make it positive. So it becomes x to the -52/4 plus 22. X to the -13 plus 22 becomes x to the +9. And that'll be the final answer. For E, slightly difficult. So we have -x to the 0.5 to the -3.6. Now what do we do? Remember this -3.6? Here's a question. Does this 0.5 apply to this, the negative sign?
Yes.
It does not. If it was like this, it would. or sorry, that's the wrong bracket position. If it was like this, then the negative 0.5 would apply to both x and the negative sign. But there's no bracket there. That means this 0.5 is strictly for the x. It does not apply to this negative. Needs a bracket in there. Like if there was a negative sign here, that 4 would not apply to this.
Mm-hmm.
But this negative 6 would apply to this negative sign. This 6 would not, but that negative 6 would. So here, this negative, this 0.5 doesn't apply to that negative sign. So look at this. When you're opening this bracket, it becomes this negative sign, or negative 1 to the power of negative 3.6 times x to the power of 0.5 times that, which is negative 1.8. Negative 1 to the power of negative 3.6. Is this, can you do this on a calculator? Will that spit out an answer, or that spit out calculation error?
Error.
Why? You know, let's look at 3.6. Doesn't really matter if it's positive or negative. We want to write this as a fraction. Do you remember how to turn this into a fraction? You want to kill the decimal point. What do we multiply this by to get rid of that decimal?
10.
So you do that on the top, you do that at the bottom. You get 36 over a 10, right?
Mm-hmm.
Which is what? 18 over a 5, right? Like that.
Mm-hmm.
So this is negative 1 fifth root to the power of 18. Can you evaluate that? Yes, it's just a 1. Negative 1 to the power of an even exponent, it's just like negative 1 squared, that's a 1. And fifth root of 1 is a 1. So that entire thing is actually just a 1. So the final answer would be just like this. Or I guess you can also write it like this. 18 is 18 over 10, or 9 over 5. And you're done. So that one is slightly tricky, which is why a calculator may not always help you in these sorts of problems. You need to be able to convert it into a fraction. And if that fraction is reducible, then there's probably an answer that exists. Let's look at the last one. Again, it's not too difficult. Square root of x6 is x3. Square root of y to the negative 6 is y to the negative 3. When you open the denominator bracket, it becomes x negative 6, y negative 2. Then this becomes x9 over y. Move this up there, becomes 3 plus 6. Move this down here, becomes negative 2 plus 3. Power 1 here, power 9 up there. And you are done. Cool?
Mm-hmm.
I'm not going to spend too much time on this. I'll just do maybe one of these. Because it just kind of came up here. It says, identify the type of function for each table of values. So here we don't have a graph, we don't have an equation, we have nothing, nada. The question is asking us to identify what this could be. This to me looks like it's a quadratic. Let's just quickly visualize it, and we're gonna be super 15, 30. Not gonna be precise here. -75, -15, -30, -45. You don't need to do this. We're just gonna make a prediction, and then we're gonna see what it actually is. So at 0, it's -45. At 2, it's -15. At 4, it's +15. At 6, it's 45. At 8, it's 75. At 10, it's 105. This is what we have, yeah?
Mm-hmm.
That is not linear. But again, my thing is not to scale. So it possibly could be. All right, so this is what we have. Looks like it's a quadratic from a rough sketch, but we can figure out what it exactly is. To know the type of function it is from a table of values, you need to find the first differences. And we're kind of only concerned with the y values here. We're going to find the difference of the y values between the y values. I'm going to go like this. What's the difference between 105 and 75?
30.
75 and 45.
It's still 30.
30, 30, 30, 30. If the first differences are the same as it is in this case, then the function is linear. If the first differences are the same. Let's say the second differences, let's say these were not the same. But let's say the second differences ended up becoming the same. In that case, that would be a quadratic. First difference the same, linear. Second difference is the same, it's a quadratic. And if the first differences, they are not the same, but are multiples. If they're multiples of each other, that's gonna be an exponential. So let's see here, if I can find one. Any of these would work, I think. Let me show you with this one. What's the difference between these two? 43 and 30.
It's 30.
That's 30. Between these two, it's 120, 480. I can't do the next one. 2563 minus 643. That's 1920. 43 minus 2563. Again, whenever you're finding the differences, you're just doing the bigger number minus a smaller number. But you can't like do this way. You do 13 minus 43, you get a -30. But then for the next one, you go this way, which will give you positive 122. You can't do that. You need to either go down this way the whole time or come up this way the whole time. For this example, I went down the whole time. That's why all the numbers are positive. The difference is numbers. So is this a linear? Look at the first differences.
No.
No. It's not a quadratic. It's probably not a quadratic. We don't know that though, but it's not a linear for sure. But here's where we can stop because 30 times 4 is 120. 120 times 4 is 480. This times 4 is this. This times 4 is that. Notice how all the first differences are multiples of each other. This represents an exponential function. If the first differences are multiples, that's an exponential. If they give you a graph, well, it's super easy then, right? Like, look at this one. Is this linear, quadratic, or exponential?
Exponential.
Here's a harder question. Is the b value, the base, positive, or is it greater than 1 or less than 1? In other words, could this be the graph for 2 to the power of x, or could it be the graph of 1 over 2 to the power of x?
1 over 2 to the power of x.
Yeah. If the y values go down as the x values increase, like over here, the x values as they increase, the y values are going down. This is called an exponential decay, in which the b value is less than 1. So it's going to be some decimal b value. Is b a linear, quadratic, or an exponential?
Quadratic.
Is the a value positive or negative? It's positive. A is positive. If it's opening up, a would be positive. What about C? Is the b value there less than 1 or greater than 1?
Less.
Less than, yeah, exactly. Because it's decreasing, decay, decreasing. If it was going up, like this one, then b value is greater than 1. Let's see if we can fill this up. It's not super difficult. Exponential growth or decay, you're strictly looking at the b values. Is A growth or decay? Look at this base. Growth. B is going to be decay. C is going to be growth. What about D?
It's decay.
It's decay. For the next column, it says, what's the initial value, the y-intercept? Remember, for the initial value or for the y-intercept, the x value or the t value, they're always 0. So all these exponents here are zeros. Anything to the power of 0 is a 1. So this entire term kind of just disappears, and you're left with the number in the front. So what's the initial value of A?
100.
Yeah, you get the idea. It's 32, it's 5, it's 600. C is slightly more tricky, the last part. It says growth rate or decay rate. The rate, if it's growth, you add to 1. So for A, the growth rate is going to be 8% or 0.08, okay? You add to 1 if it's growth, you subtract from 1 if it's a decay. So for A, the growth rate is 0.08, which is 8%. What about B? What's the decay rate? And I got 0.08 by doing 1.08 minus a 1. Because the growth or decay rates, they're always either added to 1 or subtracted from 1. So what did we add or subtract to 1 to get 0.95? Must have subtracted 0.05, right? If it's a decay, you're subtracting from 1. So just ask yourself, what did we subtract from 1 to get 0.95? Well, this turns into an equation, basically. Your unknown, it's going to be 1 minus 0.95. So you subtracted 0.05, which is 5%. What about C? What did we add to 1 to get 3?
2.
2, so it's 200%. What about D? Did we add or subtract, first of all?
Subtract.
We subtract. So what did we subtract from 1 to get 5/8? A 3/8, right?
Mm-hmm.
Look at this. 1 minus x is 5/8, where x is our rate. So therefore, x is 1 minus 5/8, which is 8/8 minus 5/8, which is 3/8. And then you multiply that by 100 to get what? 12.5 times 3, 37.5%. And you are done. Okay? So growth rate, decay rates, just look at whether the b value is greater than 1 or less than 1. And what did you add to get your growth rate, and what did you subtract from 1 to get your decay rate? Here the b value, the base, is 1/2. Is this a growth or a decay?
Decay.
It's a decay. Now this question is slightly tricky. Let's see if we can answer it though. How hard could it possibly be? So it says, which part of this equation indicates that it's an example of an exponential decay? It's the fact that your base is 1/2, which is less than 1. If your base is less than 1, it's a decay. So that's how we know that it's an example of an exponential decay. Part B, what was the initial temperature of the coffee? So when it says initial, what do we plug in as time?
Zero.
0. If you plug 0 as time in here, what do we get? Do we get 69? What is this going to be equal to?
89.
Is it 89? It'll be 90. Because this will be 69 times 1. Remember, 1/2 the power 0 is a 1. Plus 21, which is the same thing as 70 plus 20. It's 90 degrees or whatever this is. Yeah, 90 degrees Celsius, which is very hot coffee. Use your knowledge of transformation to sketch the graph. This is a little bit tricky. We're going to skip this, but I'll show you how to do it. To do a transformation, you want to compare your exponential function with something like this. So here your a is 69, your k is 1/30, your d is 0, and your c is 21, which means that it's a vertical stretch by a factor of 69. K is 1/30, which is a horizontal stretch by a factor of 30. D equals 0 means there's no left or right movement. C equals 21 means it went up by 21 units. So a very rough sketch of this. This is what the parent function looks like, 1/2 to the power of x. If you stretch it in both directions, it'll probably look something like this. And then it doesn't move left, right, but it goes 21 units up. So your final answer, you can just take these points, you move it 21 units up. Or it looks something like this. Okay?
Mhm.
Like that. The thing about exponential functions is that this is always going to be the horizontal asymptote. The c value is always the horizontal asymptote. So for this sketch, the y value will never be less than 21 degrees. So it'll look something like this, but it'll never cross 21. There's always a horizontal asymptote. Cool?
Mhm.
So what would be the minimum temperature of this coffee?
21.
21, because that's probably the room temperature. Your coffee cannot be cooler than the room temp, right? Or hotter, I guess. Eventually it'll plateau to 21 degrees. By plateau, I mean the asymptote. It'll never cross this point. All right, let's call it there for today.
Okay, thank you.
See ya.